All right, so this is an introduction to Unit 7, Polynomials and Factoring, with some vocabulary, and also we are going to do 7.1 as well. So the vocabulary that you need to know here is specific for polynomials, which we will define here in just a second. So a monomial is a singular expression made up of coefficients, variables, and or positive exponents. So you could have something simple like 3 or 3x or 3x to the third. So anything like that where it's just a single term. A binomial is the sum or difference of two monomials after combining like terms. So this would end up being something like 3x plus 3, or 3x to the third plus 3, or 3x minus 3. A trinomial is the sum or difference of three monomials after combining like terms. And what we're going to typically see is going to be something like 3x squared plus 2x plus 7. So that's a typical trinomial that we're going to be seeing a lot of as this unit progresses. And a polynomial is the sum or difference of four or more monomials after combining like terms. So it might be 4x to the fifth plus 2x squared plus x plus 7. Something like that, where there are four distinct terms that you cannot combine in any way. So a standard form for a polynomial is to write the polynomial expression in alphabetical order with the highest exponent first. So all of the ones that I have done so far have been in standard form. 3x plus 3 is standard form for that binomial. 3x squared plus 2x plus 7 is standard form for that trinomial. So you have to put the highest exponent first and alphabetical order. So if you have more than one letter, so let's say you had like 4a plus 3b squared, okay? The alphabet goes first. So even though the b has a higher exponent, the a gets to go first because it comes first in the alphabet. So standard form can sometimes be a little bit tricky, so make sure you pay attention to what you're doing. The next thing we have here is the degree of a monomial. So the degree of a monomial is the sum of the exponents of its variables. So let me zoom this in a little bit more so it'll show better on your screen. So if we had something like 3a to the third b c squared. Okay, that's a monomial. There's no pluses or minuses. So that's kind of tells you, hey, this is just a monomial if there are no pluses or minuses. So the degree of this monomial would be 3 plus 1. Remember, there's a 1 there, plus 2. So it would be 6. Okay, so you add all of the exponents together to find the degree. Degree of a polynomial is the greatest degree in the polynomial. So if we had what we had before and then plus 7a, well, the degree is still going to be 6 because this part still has a degree of 6, and that is the greatest degree for that polynomial. Now, what we typically see, so I'm going to actually just take all of this off because that's not what we would typically see in a polynomial. What we typically see is something like trinomial up here. So if I had that 3x squared plus 2x plus 7, then my degree would be 2 because the biggest exponent in this polynomial is 2. So you are looking at the exponent. I'm going to write that over here. As a reminder. Okay. Then we get into some specific names for the degree of a polynomial. So that's why these are kind of off, set in like this, indented, because they actually go along with degree of polynomial. So if you have a polynomial in the form of y equals mx plus b, then that's going to be the degree of 1. Notice the x right here, it would be like it had an exponent of 1. In fact, everything in this polynomial has the exponent of 1. Now, linear, this should make sense to you because you know this is the equation of a line. So that's why it's called a linear polynomial. So I'm going to give you an actual example of one. So you could have something like y equals 2x plus 4. But you could also, remember standard form, you could also have 2x minus y equals negative 4. Okay, so that would be the same thing as what those two are actually the same line. So it could be written either way. Notice x comes before y, so alphabet likes that. And you could even do it like this. If you, instead of having the equal sign, you could even have plus 4 like that, like just as an expression. And then that's still a polynomial, and it's still linear because it has a degree of 1. Quadratic is a polynomial of the form y equals ax squared plus bx plus c, and a has a degree of 2. Actually, a doesn't have a degree of 2. X has a degree of 2. So a, the coefficient isn't the one with the degree. So just like we wrote on several of these before, we could have like 2x squared minus 3x plus 4. So something like that would be a polynomial that is a quadratic because the x has a degree of 2 right here at the beginning. And things like that can also be written with the y in front if you're going to graph it. We'll get more into that in Unit 8. And then a cubic is a polynomial in the form of y equals x to the 3. And again, x has a degree of 3. So you could have something simple like y equals x to the 3rd power. That's a cubic polynomial. Or you could have something more complex like 4x to the 3rd plus 2x squared minus 3x plus 7. Something like that. Or you could have the same thing but with a y in front of it. So all of those are kind of the same, saying the same thing, but because 3 right here is the largest exponent, that makes it a cubic polynomial. Right, next page. We've got just a few more terms. So a constant is a number without any variables. So like 3 or negative 7. Numbers like that are constants. We know that. We've already talked about that. Coefficient is a number in front of a variable. So if you had 2x or negative 5x to the 3rd, the coefficients would be the number in front of the variable. So that's the coefficient. A term is a single monomial within a polynomial. So if we were going to have, we'll just use these numbers we already have here, negative 5x to the 3rd plus 2x minus 7. Then a single monomial here, or a term, like negative 5x to the 3rd is a term. 2x is another term. Negative 7 is another term. So each individual number separated by those pluses and minuses is a term. The leading term is the first term when a polynomial is written in standard form. So if we look at this previous problem, then negative 5x to the third is that leading term. So hopefully that will make sense when you look at that later, that the leading term is negative 5x to the third. The leading coefficient is the coefficient of the leading term. So again, if we look up here, it's negative 5. Okay, so the first term was negative 5x to the third, and then its leading coefficient is just the negative 5 part. All right, so something really important when we're working with polynomials is to get them in standard form, be able to identify some parts in them. So to get them in standard form, you always want to look first and make sure of how many variables you have. So in number 1, we only have x, and so we don't have to worry about alphabetical order because x is x. Then you want to look at which one is the biggest exponent, and it is this term. So that one gets to be the leader. So it's going to be 3x to the 6th power. Then you look for what is the next biggest exponent, and it is going to be 2. So 9x squared gets to go next. And then minus 4x just has a 1. Remember that we don't write, so it has to go last. So then you're going to look for the biggest exponent to answer what is the degree. The degree is 6 because the biggest exponent is 6. And the leading coefficient is just that number out front, which is 3. All right. Number 6 is a little bit more complex because it has x's and y's. So for this one, we're going to start with, is there an x by itself? And there's not. All right. Is there an x that has a bigger exponent than 1? No, there isn't. So we've got xy and xy squared. So since x is the same in both of those, 8xy squared gets to go first because it has this larger exponent. And then we're going to have plus 6xy and then plus 5y. Now 5y has to go at the end because it doesn't have an x at all. So remember, the alphabet determines first, followed by the exponent. So the degree for this would be 3. The reason for that is because x, remember, does have a 1. So 1 plus 2 is 3. And the leading term is, of course, 8 because 8 is the number out front. All right, number 3 is tricky because it looks like it's a trinomial because there's 3 terms, but it's actually not a trinomial. Remember in the definition over here that a trinomial is the sum or difference of 3 monomials after combining like terms. Well, if we look at this problem, these are like terms. So we need to combine them first. So 6x to the third plus 4x to the third is 10x to the third. Remember, you don't change exponents unless you're multiplying or dividing. And then we'll have minus 5 because it doesn't have an x, so it cannot be combined with the other ones. So if the x's have the same exponent, then their coefficients can be added together. So the degree here would be 3 because the largest exponent is 3. There aren't 2 letters, so there's nothing to add together. The leading term is 10. After we add those like terms together, we do get 10. And then we have a new question. Is this a binomial or a trinomial? Well, if we looked just at the beginning of this, we would think, oh, that's a trinomial. But after we combine the like terms and we're here, we can see that that is a binomial. So we're going to put a box around binomial, not trinomial. All right, some similar things happen in the rest of these. There's some things to combine together. Well, number 6 is not, but 4 and 5 you do. So we've got some like terms here. So 4x squared is not going to change because there is not another x squared. 6x plus 8x is 14x. So you just add 6 plus 8. And then we've got minus 2. Just like before, we're going to look for the biggest exponent. That is 2. The number of terms here is, here's a term, here's a term, and here's a term. So remember, terms are separated by pluses and minuses. So there are 3 terms, and the leading coefficient is 4, because there's a 4 in the front. All right, in number 5, we have 4x squared plus 6x squared minus 8x squared. They're all x squareds. So that means that they can all be combined. So when you combine, you're just adding together 4 plus 6 and then minus 8. So you can do that part in your calculator. So that part would be 2. That would equal 2. So that means your answer is going to be 2x squared. So when you combine all those x squareds, that's how many you have. So the degree for this is 2. Remember, the exponents don't change when you're adding and subtracting. The leading coefficient is 2, because that's the only coefficient. And this is a monomial. So because we have no pluses or minuses, when we get finished combining, it's a monomial. It's just this one single term. And so it's a monomial. And then in this last one, you really think, you've been combining things, been rearranging things. This one is actually correct the way it is. So you've got x squared y. So x is first alphabetically, and it has the biggest exponent. Then we have x by itself, because it comes before y, which is by itself. And then the constant is always last. It doesn't have a letter at all, so it's always last. So we actually cannot combine anything, and nothing needs to be rearranged. So this one is correct the way it is. So the degree of this one is 2, and the constant for this one, oh, we haven't had this question yet. The constant for this one is 9. It's the number without a variable. All right. I'm going to stop this video, and I'm going to do 7.1, which is adding and subtracting polynomials, in a new video.